Good morning. So I've got some time here in the morning for a shorter one. Um, Keep my eye on the clock around 8:50. I should need to log off. The last video I did was machine learning for cloud and network engineers. This book is turning out to be pretty awesome. Already, I've got a key takeaway from the book. The first key takeaway is that where automation now and in the past has consisted of, instead of humans doing things, now we have machines doing things. So where we ask on the network, or just more broadly in general in society, where, what, when, why, how, we can automate the how. We can have something happen by, so if we ask the question, how will this happen, the answer can be by a machine through automation. So the goal of automation, the next era of automation, especially network automation, is to automate more than just the how, specifically um, the why. We're gonna automate the why now. So we're going to switch on from automating just actions to also automating decisions. So we're before we would have to think of something to automate, but then we have that advantage of answering of having the machine going and automating that however it decides to do that by setting it up to answer the how. Now we can also answer the why, and instead of having to think of what needs automation, we can have a machine make those decisions. So while I will elaborate more later, this book is, in summary, for people like me, network and cloud engineers who want to understand about AI. Let me explain my journey and why this book may be helpful for you if you fit the short description above. So, everyone on this channel should fit that description. I certainly fit that description very well to a T. So, this is a perfect next book to read. Most of my career has focused on networking, myself as well, whether service provider or enterprise networking environments, myself as well. So we have a very similar career, me and the author. Ethernet, IP, BGP, MPLS, segment routing, that's SR, we learned about that last time. Campus, metro, backbone, peering, data center, etc. Yeah, those are all very familiar terms to me. In my journey, both in system integrators and networking vendors, I have worked with customers to design, deploy, and operate their network infrastructures. More often than not, traditionally, most of the focus was on the technology, the capacity, the protocols, and the functionality supported. Over the past 10 years, a substantial shift happened toward network automation. It was no longer about the protocols supported and or the packets per second, but also about how to improve the network outcomes via automation. Fewer human errors in configurations, faster execution of methods of procedure, etc. And I will add to that as well, more round the clock operations on the network. So if you can have something, just some small thing occur all hours of the day, that's better, especially when you have some small maintenance instead of having someone stay up at night. If you can automate that, then that's a huge win. I personally focused more and more on automation and transitioned towards product management roles where I could help drive more and better automation solutions back when I was working at Juniper. However, still there was a missing piece. While we had better tools to automate tasks, what task to execute depended on human knowledge. There is nothing fundamentally wrong with that, but as networks become more complex and mission critical, the human dependency on some tasks may result in longer than acceptable reaction times. Alternatively, even in the impossibility of reacting because the problem is too complex for a human to address. Yeah, so this a lot of the writing is difficult. You can tell that the author is speaks English as a second language. The author's from Spain, so I guess that's a bit of an assumption. Maybe they, but I would assume that their first language is Spanish. And you can kind of tell that because some of these sentences are a bit difficult to read, but I don't feel like any of the meaning is lost. There was a clear need to help humans augment human-based decision processes so that the more strict SLAs on networks could be met. Network telemetry interest grew as an enabler in obtaining more data from the network, sometimes more real-time data. And I'm a little bit unfamiliar with network telemetry, so let's ask ChatGPT. And we'll go back to the original one. Tell me about network telemetry.
Network telemetry refers to the collection, analysis, and use of data about the operation of network, often in real time or near real time. This data provides valuable insights into the health, performance, and security of network infrastructure and services.
Yeah, monitoring.
Network telemetry is crucial for proactive management, troubleshooting, capacity planning, and security monitoring in modern network environments. Key components of network telemetry. Network telemetry involves several components and methodologies. Data collection. This is the process of gathering data from various parts of the network, such as routers, switches, firewalls, and other network devices. Data collected can include metrics on traffic flow, device status, configuration changes, and security events. Data transport. Once collected, the data needs to be transported to a central system for processing. This is typically done using protocols like SNMP, Simple Network Management Protocol, Syslog, IPFIX, Internet Protocol Flow Information Export, or more modern methods like gRPC or GNME, which offer more efficient and real-time data transport. Data analysis. The received data is analyzed to extract meaningful insights. This analysis can be performed using custom scripts, specialized software, or more sophisticated machine learning algorithms depending on the complexity of the network and the specific requirements. Visualization. The analyzed data is often visualized in dashboards that provide network administrators with an intuitive understanding of what's happening in the network. This can help in quick decision-making and problem-solving. Action and automation. Advanced telemetry systems can trigger automated actions based on specific conditions or anomalies detected in the telemetry data. This can include adjustments in network configurations, alerts to administrators, or even automated security responses. Benefits of network telemetry. Network telemetry offers numerous benefits. Improved network performance. By monitoring network traffic and performance metrics, administrators can identify bottlenecks and inefficiencies, leading to better network optimization. Enhanced security. Telemetry data can help identify unusual patterns that may indicate a security breach, enabling faster and more effective responses to threats. Proactive problem resolution. Real-time data allows network operators to detect and resolve issues before they affect users, improving overall service reliability. Operational efficiency. Automation of network monitoring and management tasks reduces the need for manual intervention, saving time and reducing operational costs. Modern developments. The evolution of network telemetry has been influenced by developments in software-defined networking, SDN, and network functions virtualization, NFV. These technologies allow for more granular data collection and dynamic network management. Additionally, the rise of machine learning and big data technologies has enhanced the capabilities of network telemetry systems, enabling more predictive and intelligent network management. In summary, network telemetry is a vital component of modern network management, offering detailed insights into network operations and significantly improving the ability to manage, secure, and optimize large and complex networks.
Act as an expert and design a network telemetry solution.
Designing a network telemetry solution involves several steps, from selecting the right technologies and protocols to ensuring that the system is scalable, secure, and efficient. Here's a detailed plan on how to design an effective network telemetry solution. Step 1. Define objectives and requirements. Before diving into the technical details, it's crucial to define what you want to achieve with your network telemetry system. Consider the following: performance monitoring, metrics like latency, bandwidth usage, and packet loss. Security monitoring, detection of anomalies and security breaches. Configuration and system health monitoring, status of devices and alerts for any critical incidents. Scalability and flexibility, a system should adapt to growing or changing network architectures. Step 2. Identify key data sources. Determine where your telemetry data will come from. This includes network devices, routers, switches, firewalls, and wireless access points. Servers and applications, especially if they impact network performance. End-user devices. In certain contexts, data from end-user devices can be crucial. Step 3. Choose telemetry technologies and protocols. Select the protocols and technologies that will form the backbone of your telemetry system. Common choices include SNMP, Simple Network Management Protocol, good for basic device monitoring but limited in scope and performance. Syslog, useful for gathering logs from various devices for security and performance monitoring. IPFIX, NetFlow, essential for monitoring traffic flows and understanding traffic patterns. gRPC, GNME, modern protocols for efficient, real-time monitoring, especially in programmable networks. Streaming telemetry, utilizes protocols like gRPC to stream data directly from devices to a telemetry system in real time. Step 4. Data aggregation and storage. Decide on a strategy for data aggregation and storage. Time series databases. Databases like InfluxDB or Prometheus, optimized for storing and querying time series data. Data lakes. For more extensive data collection that includes logs, packets, and flow data, consider using a data lake solution. Step 5. Data analysis and visualization tools. Select tools that can analyze the collected data and provide actionable insights through dashboards and reports. Options include ElkStack, Elasticsearch, Logstash, Kibana for log analysis and visualization. Grafana for creating dynamic, real-time dashboards. Machine learning tools. Implementing AI for predictive analytics and anomaly detection. Step 6. Security and compliance. Ensure that your telemetry system adheres to relevant security protocols and compliance requirements. This includes data encryption, both in transit and at rest. Access controls. Limiting access to telemetry database and user roles. Audit trails. Keeping records of data access and changes for compliance. Step 7. Implementation plan. Create a phased implementation plan. Pilot project. Start with a small segment of your network to test the telemetry solution. Phase rollout. Gradually roll out the system across the network based on the success of the pilot. Continuous evaluation and optimization. Regularly assess the system's performance and make necessary adjustments. Step 8. Training and documentation. Provide training for network operators and administrators on how to use the telemetry system effectively. Additionally, ensure thorough documentation is available for system maintenance and troubleshooting. Step 9. Feedback loop. Establish mechanisms for feedback on the telemetry system's effectiveness from users and technical staff to continuously improve the solution. This comprehensive approach to designing a network telemetry system will help ensure that it not only meets the current needs of the network but is also scalable and adaptable to future requirements.
Alright, moving on. Data is necessary but not sufficient. We need insights. We need actionable outcomes. It has become clear that network operation needs to be assisted by analytics techniques that transform the raw network telemetry into actionable insights that can complement and augment humans operating the network. And I'm going to take a quick pause. I'll be right back. Alright, I'm back. I got a little bit of time here, but it's going to be a short video. So AI/ML represented a great promise. However, what is AI/ML? For the most part, I would see at that time AI/ML as a magic black box that you push data through. And it somehow produces results. I did not understand how it worked. Throughout my life and career, I've always felt intrigued and motivated by what I did not understand. So my interest shifted towards building a solid understanding of what's inside that black box and how to use it to drive better outcomes in networking. That is where my journey started to bring together AI/ML with networking. However, it has been a challenging ride. As a network engineer, I'm used to consuming technical books, so I did that. I consumed AI/ML books like there was no tomorrow. Algorithms, theory, ML frameworks, etc. I tried by myself to build and understand the big picture for a long time, but it was not easy. Sometimes books will not be focused on the big picture, but in the algorithm detail and mathematical theory behind. Nothing is wrong with that, but I frequently feel lost. I did countless courses on multiple platforms, Udemy, Coursera, MIT, etc. Still, I needed to consolidate the knowledge in the way I thought I needed. That led me to take the next step and take a data science and deep learning masters at MIOTA School in Madrid. I wanted to consolidate and better structure my understanding, and in that process, have the opportunity to strengthen the applied and practical aspects of it. Needless to say that doing a master's while working 12 hours a day is quite a challenge. So he went to school while working full-time. I want to learn more about that school, so I plugged it into ChatGPT.
MIOTI Tech and Business School, located in Madrid, Spain, specializes in offering technology and business-related educational programs. They are known for their focus on the latest trends and technologies, such as data science, Internet of Things, IoT, and machine learning, which are all crucial for advancing in today's rapidly changing digital landscape. Relevance to machine learning for network and cloud engineers. In the context of Javier Andic's book, Machine Learning for Network
I
and
like
Cloud
this one
Engineers,
better.
a school like MIOTI can be especially pertinent for several reasons. Educational focus. MIOTI's emphasis on IoT and data science aligns well with the needs of network and cloud engineers looking to integrate machine.
Okay, so tell me more about this school, like in the context of other schools. Let's say that we compare it to the school UW-Madison in the USA and the school UT in Austin, Texas. So, like, is it more difficult to get into these schools than that one? Yeah, they have broad focuses. Admissions are based on. Okay. I'm just curious about that because I feel like that could be a really good option for me. As a network engineer, this has helped me connect the dots to understand with complete clarity what algorithms are available to solve what problems. As network engineers, we know what problems need solving. It is now much easier to evaluate if there is an AI/ML technique inside that black box that may be used, what the feasibility is, what data is required, what process would be necessary, and what could be the expected outcomes. The black box turned into a toolbox. Now I can judge with reasonable confidence if there is a tool and what tool it is to solve a particular problem. Even if we are not implementing it, we now have the opportunity to judge. Network engineers are a special type of engineer. We never stop learning. We cannot, indeed, because network technology evolves at such a pace that we would be very quickly obsolete if we relax. However, in addition to that, about 10 years ago, network engineers realized we had to complement our skills with automation, scripting, Python, Ansible, SaltStack, etc. It became a fundamental skill for a network engineer as automation was integral to the network lifecycle. AI/ML will play the same role in the next 10 years. A strong understanding of AI/ML techniques and problem solving with them will become similarly important for a network engineer as automation has been in recent years. I believe that network engineers who lack such understanding will miss opportunities and face more challenges than those who develop them. This book is, therefore, for those network engineers willing to embark on this journey. It is for those like me who need to understand what is inside that black box. I'm writing this book to make it easier for you to go through that process and help you learn about AI/ML from a networking use cases perspective. My journey took me a few years and lots of money and time invested and sometimes wasted. My goal with this book is to make it easier for you, to package the right level of information, theory, and practice for you to achieve the goal you need as a network engineer. If you want to dig deeper, there is an almost infinite amount of literature for sure. I will recommend you some at the end of the book. The book will have practical examples of applying different AI/ML techniques to real network use cases. I really want you to see it working, and possibly, if you feel like doing it, you can take the code and modify or improve it yourself. If you are a network engineer who has already initiated the journey I started years ago and is somewhere at a midpoint, this book will also be useful. It will provide you a big picture view, a recap, a review of use cases you may not have evaluated yet, and techniques you may not have explored yet. The practical examples will help you familiarize yourself so you can dig further with deeper and more specific literature. I'm not trying to encourage you to build your AI ops tool, but feel free to do it if it motivates you in your organization. Oh, it does. It really does. However, I do encourage you to learn, to understand what is behind and underneath each of the many techniques that I will explain, because knowledge will only make you a better professional. Your ability to distinguish what is doable, what is not, what is real, and what is hype will help you make better decisions, whether you build your own solutions or purchase commercial ones. While I've built examples for a wide range of use cases and techniques, I want to emphasize that it has not been my intent, nor do I claim to use the best AML models for those use cases or the most optimized models in terms of hyperparameter choice. However, they are good enough to illustrate the opportunity to address a network use case with machine learning. I am more interested in helping you connect the dots than in providing the optimal model or the optimal code for that matter. I'm a lousy coder and I'm a mediocre data scientist. So don't expect perfect code or optimal models. I'm what? Okay. I'm a good father though, for what it's worth. I kind of don't understand how that's relevant. My goal here is to help you connect the dots. I will not give a profound mathematical explanation for the details and algorithms. I myself could be a better authoritative voice for that matter, and there is plenty of literature. I will explain things using the language I think will be good enough for a network engineer to understand. If you want to understand its deeper mathematical rationale, I encourage you to research and read over literature focused on those algorithms. If you are a data scientist, this book may not be for you. This book will offer you an applied perspective of the type of problems the networking industry faces and the connection with the type of solutions that could be relevant. The practical examples you will find are not, as I referred to earlier, in any sense optimized, nor I intended to. This book may also be for you if you are a software developer in the networking industry. It may give you both visibility on real network operation problems that service providers and enterprises face and ideas on how they can be addressed using AI/ML. This book may trigger you to investigate further and augment your software development skills with an applied view using AI/ML. And I'm very rapidly running out of time, but I can make it to the end. This book is also for you if you are a network operations manager, director, CTO, or CIO. While some of the more detailed sections and code examples may not be interesting, you are likely participating in conversations with the industry about the wonders of AI/ML, or perhaps you believe that AI/ML can help your operations team to improve. However, perhaps the opaque black box view is preventing you from being able to define the right strategy and priorities. This book may give you insights and criteria to determine the right path. It may help you quickly filter the hype from the tangible reality when taking part in conversations about AI/ML. All in all, as always, knowledge is power. This book will catalyze better knowledge and perspective and help you fit all the puzzle pieces together. If you are simply a person, not necessarily a network or cloud engineer, willing to have a broad introduction to AI/ML with some practical examples. I think this book may also be for you. Some of the use cases and network-specific terminology may indeed sound alien to you. However, the overall review of ML, the principles, and the description of the algorithms, ultimately the big picture, is explained so that you can get a good understanding and benefit from reading the book. If you expect to become a data scientist just by reading this book, I can tell you now, you will not be one. No book by itself will be enough, by the way. After reading this book, you can expect to be an amateur data scientist or a mediocre one at most, but you will be a much better network engineer. This is a book written by a network engineer for network and cloud engineers. Perfect. That's exactly what I want. So the next video, why did I write this book? We'll start right here. So I'm gonna end perfect, good ending part. So I've got the bookmark all set up. Location 204. That's where we're at. So that's it for this video. Thanks for watching, and stay tuned for the next one.